The directions say to determine whether the sequence converges or diverges. If it converges, find the limit. Let's take a look at example 1. Suppose a sub n is equal to 4n squared minus 2n divided by 2n squared plus 1. The limit as n goes to infinity of a sub n is equal to the limit as n goes to infinity of 4n squared minus 2n over 2n squared plus 1. So to go from the first line to the second line, we're going to factor out an n squared from the numerator and an n squared from the denominator. And when we do that, we get the limit as n goes to infinity of n squared times the quantity 4 minus 2n over n squared divided by n squared times the quantity 2 plus 1 over n squared. So to go from the second line to the third line, notice that the n squareds end up canceling out. And if we take 2n over n squared, this is the same as 2n divided by n times n, okay? The n's cancel, and we're left with 2 over n. And so this is the limit as n goes to infinity of 4 minus 2 over n divided by 2 plus 1 over n squared. But by the limit laws, this is equal to the limit as n goes to infinity of 4 minus 2 times the limit as n goes to infinity of 1 over n divided by the limit as n goes to infinity of 2 plus the limit as n goes to infinity of 1 over n squared. So next page. This is equal to 4 minus 2 times 0 divided by 2 plus 0, which is equal to 4 over 2, which is equal to 2. And what that tells me is that this sequence converges to 2. And that's example 1. Example 2. Suppose a sub n is equal to 2 plus 0.86 to the nth power. The limit as n goes to infinity of a sub n is equal to the limit as n goes to infinity of 2 plus 0.86 to the nth power. So by the limit laws, this is equal to the limit as n goes to infinity of 2 plus the limit as n goes to infinity of 0.86 to the nth power. Now, let's take a note here. The limit as n goes to infinity of r to the n is equal to 0 if the absolute value of r is less than 1. And notice that the absolute value of r, if we go up here to the second line, the absolute value of r is equal to 0.86, which is less than 1. And so what that tells me is that the limit as n goes to infinity of 0.86 to the nth power, that's going to 0. And so, therefore, the limit as n goes to infinity of 2 plus the limit as n goes to infinity of 0.86 to the nth power, this is equal to 2 plus 0, which is equal to 2. And from here, we can say that the sequence converges to 2. Let's take a look at example 3. A sub n is equal to 3 to the n times 7 to the negative n. But if we use our laws of exponents, we can say the following. 3 to the n times 7 to the negative n is equal to 3 to the n times 1 over 7 to the n. But that's equal to 3/7 to the nth power. So the limit as n goes to infinity of a sub n is equal to the limit as n goes to infinity of 3/7 to the nth power. Now, this is equal to 0. Why? The absolute value of r is equal to 3/7, and that's less than 1. And so that tells us that this sequence converges to 0. and that's example 3. Let's take a look at example 4. Suppose a sub n is equal to n to the fourth over n to the third minus 2n. The limit as n goes to infinity of a sub n is equal to n to the fourth divided by n cubed times the quantity 1 minus 2n over n cubed. So I just factored out an n cubed from the denominator. Now, a couple of things. Notice that n to the fourth over n to the third is equal to n to the 4 minus 3, which is n to the first, which is equal to n. I realize that's overkill, but I'm going to go over it in this video. And then remember that 2n over n to the third is equal to 2 over n squared. So on the next line, we can write the limit as n goes to infinity of n over 1 minus 2 over n squared. But as n gets large, 2 over n squared goes to 0. So what you're essentially getting is infinity over 1, which is equal to infinity. And infinity is a concept. It's not a number. Okay? It's just a fancy way to say that this limit doesn't exist. And what that tells me is that this sequence diverges. We didn't get a fixed number back. Okay? That's example 4. Let's take a look at example 5. Suppose a sub n is equal to the natural log of n plus 1 minus the natural log of n. Well, the natural log of n plus 1 minus the natural log of n by the properties of exponents, this is equal to the natural log of n plus 1 divided by n. But this can be written as the natural log of 1 plus 1 over n. Now, let's observe something. The limit as n goes to infinity of 1 plus 1 over n is equal to the limit as n goes to infinity of 1 plus the limit as n goes to infinity of 1 over n. But this is equal to 1 plus 0, and that's equal to 1. Okay? So what does that mean? This says that the limit as n goes to infinity of a sub n is equal to the limit as n goes to infinity of natural log of 1 plus 1 over n. But this is equal to the natural log of the limit as n goes to infinity of 1 plus 1 over n. And that's equal to the natural log of 1, which is equal to 0. And so from here, we can say that the sequence converges to 0. And that's how you do example 5. And what I'd like to do for this video, I want to go over one more example. And that right there is example 6. Suppose a sub n is equal to cosine squared n divided by 2 to the n. Okay? Now, this is what we're going to do here. If I look at the absolute value of a sub n, this is equal to the absolute value of cosine squared of n divided by 2 to the n. Okay? Now, this is greater than or equal to 0. Okay? Right off the get-go. And I claim this is less than or equal to 1 over 2 to the n, which can be written as 1/2 raised to the nth power. Okay? Now from here, we can say that the limit as n goes to infinity of 1/2 to the nth power this is equal to 0. And let's note something here. The absolute value of r is equal to 1/2, which is less than 1. So by the squeeze theorem, we can say the limit as n goes to infinity of the absolute value of a sub n is equal to 0. But it turns out we can show that if the limit as n goes to infinity of the absolute value of a sub n is equal to 0, we can say that the limit as n goes to infinity of a sub n is equal to 0. And so, therefore, we can say that this sequence converges to 0. And that's how this problem worked. And that'll do it for this video. This is a video on determining whether or not a sequence converges or diverges. Okay, thank you.